Hope you're having a great evening today. So I am Munsif currently working as an associate machine learning engineer at Rootcode AI. Today we are going to discuss about one of the most fascinating and the hottest topic in the field of AI today, the multimodal AI. So before we move to the specifics of multimodal AI, I want to take a moment to highlight a significant event that happened in the November of 2022, which had a big impact on the field of AI. Any guesses? Like you guys have been using like on a daily basis. Yeah, probably some of you have already guessed it. Yes, OpenAI launched ChatGPT. We all went mind blown by its capabilities, right? It took the world by storm within a few days, and it revolutionized the way we interacted with AI before. So it was like some kind of an instant success. So it revolutionized the way we interact with AI before. So ChatGPT was an instant success, and this success of ChatGPT led many other big tech companies to release their own large language models. Like Google released their Palm versions, Meta released their Llama models, and Anthropic released their Claude models, and Mistral had their own large language models. These large language models can generate human-like text. They can write poems, they can write stories, they can write content for videos, they can even solve really, really complex math problems. A year back, when these big tech companies releasing their own large language models, everyone had these remarkable large language models with highly capable models. Everyone had a same question. What's next? What more these LLMs can do? So if we were to answer this question today, the answer is most probably multimodal AI. So before going to the definition of multimodal AI, a central question needs to be addressed: how a human brain works, how a human brain processes information. Let's look at this video for a bit.
Ba 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 ba.
How many of you here heard two sounds? Raise your hand if you heard two sounds here. Yeah, some of you heard two sounds, but in actually, it's the same sound played throughout the video. But some of you heard two sounds here, right? But why does this happen? This is what we call the McGurk effect. What happens is our eyes and ears got together and tricked our brain to think that we heard two sounds, even though just because the man in the video he moved the mouth in a different way, we think that he made two sounds, but it's the same sound played throughout the video. So this shows how our brain processes information, how our brain combines multiple modalities to make a joint representation of this world. As we humans, we rely on multiple senses such as sight, sound, and taste to make sense of this world. Our brain effortlessly integrates these multiple inputs and allowing us to see the world as a whole. So multimodal AI aims to replicate this ability in machines. So by combining multiple modalities, we can create AI systems that can understand intent and context way better. So this brings us to the core of our discussion. What is multimodal AI? So before moving into the definition of multimodal AI, I want to let you guys know the meaning of word modal in the multimodal AI. What does this word modal means? So modal or modality in this context of multimodal AI refers to a type or form of data that an AI can understand and process. For example, an image can be a modality, a video or audio, anything that a machine can process that we call the modality. These are images, audios, and text are examples of modalities. Okay, now, so what multimodal AI means? So by definition, multimodal AI is a type of AI system that can process data from multiple modalities and create output in multiple modalities. This basically means that multimodal AI not just can take multiple types of data like text, speech, images as input, but can also output text, image, audio, and video. This is actually the primary difference between the models we had before, like GPT 3.5, Palm 2, or DALL-E, which are basically called as unimodels. To understand this better, let's compare the difference between these unimodels and multimodal AIs. So unimodels are models that are designed to understand, interpret, and generate output based on one type of data input. It could be text, it could be images, it could be sound. But the key point is unimodal systems specialize in single mode of data type. For instance, consider a scenario. You are trying to design a t-shirt which you saw on the internet, but you want that t-shirt in a darker color. So if you use a unimodal AI like vision only AI, what it does is it sees the image in the t-shirt, it doesn't understand the text. It will generate t-shirts which are in similar design but not in a darker color. But if you use something like a text to image model, it doesn't understand images, it only understands text. So if you ask like shirt like this but in a darker color, it will generate t-shirts in dark color but not in a similar design. These are all unimodels. This is the issue with the unimodels. They only output and input one particular type of data. But however, multimodal AI systems are advanced AI systems that can process and correlate information across different types of data input simultaneously. This integration allows multimodal AI for complex understanding and more generation capabilities. With multimodal AI, you can upload the photo of the t-shirt and type a request something like shirt like this but in a darker color. It combines both the input, it sees the photo in your t-shirt, it understands that you are asking for a t-shirt in a darker color, and it will generate a t-shirt that in a darker color as you wanted. So the multimodal AI provides much better result. It shows you the t-shirt that matches the style in your photo but in a darker color just like you wanted. But even before we had multimodal AIs like GPT-4o or Gemini, we had Microsoft Bing Chat and Google's Bard, which let you to upload images and audios and have a conversation with it. But the core model behind these models were GPT-4 and Palm 2, which are basically unimodels. But how did they achieve these multimodal AI capabilities with these unimodels? Some of you have already guessed it. Basically, they are using a pipeline of unimodel. Let's say, for instance, let's say you go to a Bing Chat and put an audio something like draw a picture of rabbit. What they do is basically they fed that your audio input to something like a speech to text model like a whisper to get to a text. And this converted text will be fed to a GPT model to interpret the user input. And this user input will be fed to a model like a text to image model to generate the image of the rabbit you wanted. We are here performing an audio to image, but in reality, we don't have an audio to image model, but instead of here, we are using an audio to image pipeline. But if we can create a multimodal capabilities with this pipeline of unimodels, why do we even need multimodal AIs? Mainly for two reasons. The main reason is the speed. When we use a pipeline of model, we use separate models. Each one deals with only one type of data at a time, and the output of one model will be fed to another. So this process can be really slow because we are processing only one type of data at a time. A model that can handle all types of data at once can be really efficient because it processes all the information together, which leads to faster inference time because it doesn't have to waste time relying on another model's output. Another reason why we prefer multimodal AI over unimodal AI is the accuracy. Each model understands its own type of data, but combining the results can be really tricky and may lead to mistakes. A single model that handles multiple types of data have been trained to understand the interaction between different types of data inputs. It understands the interaction, so it can see a bigger picture and make better decisions. This leads to more accurate results because the model understands all the data together, not just in pieces. Now you might be wondering, how exactly do we create these powerful multimodal AIs? That question brings us to the fascinating process of training these multimodal AIs. How we train this multimodal AI? Multimodal training architecture typically consists of three important modules. First one is the input module. which uses different types of neural networks and encoders to pre-process different type of data inputs. Then comes the fusion model. Fusion model is the heart and soul of multimodal AI. This is where the processed data from input model will be combined and interpreted. And finally, we have the output model, which generates the final output based on the processed and fused data. To better understand this process, let's dive deeper into each and every model and understand how they contribute to the functioning of multimodal AI systems. Let's start with input model. This is where the journey of data begins in a multimodal AI system. This module is responsible for ingesting and pre-processing different types of input data. This module is crucial as it ensures the various types of data are effectively pre-processed and encoded. For example, if we have a multimodal AI system that understands images and text, we'll have a separate text encoder component for text and separate image encoder component for images. These components ensure that the data is in a suitable format for AI to understand. The input model might also consist of a feature extraction component just to extract the important features from each and every input modality. Now, once the input data has been prepared, it's time to move to the next critical phase, the fusion of these modalities. As I said earlier, the data fusion is the heart and soul of multimodal AI. Before we dive deeper into the data fusion, it is essential to understand the building blocks that enable this complex data fusion process. To understand data fusion, we need to know mainly two things. One, how unimodal AI systems like ChatGPT or text-to-text LLMs work, and the concept of embeddings. Now let's turn our attention to how unimodal AI systems specifically like something like a text-to-text LLMs work. Let's say you went to a ChatGPT kind of a LLM and asked a question like, explain quantum physics. LLMs have two important parts. One is an encoder, other one is a transformer decoder. What encoder does is, it takes this user input, explain quantum physics, and convert it to a mathematical representation, something we call as an embedding or context vector. And this embedding or context vector will be fed to a transformer decoder. It will be used to generate a user input, in this case something like quantum physical science that describes something like that. The key part of this process is the creation of embeddings, which act as a bridge between encoder and decoder. Actually, this embedding allows the decoder part of the model to grasp the meaning and the purpose behind the user input and generate a response that is coherent and relevant to user input. So what are these embeddings or the context vector? Some of you already have an idea of what embeddings are. For those who don't know, embeddings are the unsung workhorses of today's AI. Some of the world's widespread and commercially important applications of AI are powered by these embeddings. So what are embeddings really? So we all know machine can't understand words, text, or images. They only understand numbers. So we need to convert all these input like images, text, and audio to some kind of numbers. This number is what we call the embeddings. Embeddings aren't just a bunch of random numbers. They are sophisticated array which captures the essence of the input, including its meaning, context, and even the nuances in the input. Let me explain deeply how good these embeddings are in capturing information in the user input. Consider these two sentences. So in the first, we have this sentence with the bank. So in the first sentence, I need to deposit money at the bank, and second sentence, we had a picnic by the river bank. The word bank in the first sentence refers to a financial institution, and in the word bank in the second sentence refers to a side of the river. As we humans understand the word banks has two different meaning while reading this, AI also should understand that. AI actually used the surrounding words to understand the meaning of the word by creating an embedding for each and every word. For instance, in the first sentence, the words like deposit and money guides the AI to understand the word bank in the first sentence refers to a financial institution. And the words like picnic and river guides the AI in the second sentence to understand the word bank in the second sentence refers to a side of the river. So embeddings are usually represented in a higher dimensional vector. It can be 1096 vectors. It can be usually represented high dimensional vector. For the sake of this discussion, let's assume we can represent the dimension, represent the embeddings in a two-dimensional space for the word bank. So since embeddings were created based on the meaning of the word, if we plot the embeddings of the word bank in the two sentences in a two-dimensional space, they will be far apart. And words like loan and account will be placed closer to financial institution bank because they are related to financial institution. And the words like shore and water, which are related to river, will be placed closer to the word bank, the river side of the river bank. So when you use the bank in a user input, AI use these embeddings to determine the intended meaning, whether you are meaning a financial institution or the side of the river bank. Here we saw embeddings for the text. However, creating embeddings for different modalities have a different ways to create embedding for different modalities. For example, we can use something like a convolutional neural networks to create embeddings for images. Their ability in identifying patterns and features in visual data can be used to create embeddings for images. For text data, we can use something like RNN or transformers to create embeddings. These transformers are highly skilled at understanding sequential information and capturing context of the words. As for audios, we can use something like melt frequency substrate coefficient or MFCC to process and embed audio signals. For videos, we can use something like combination of CNNs and transformers to create embeddings for videos. This architecture preposes these different types of modalities and output and embedding essentially in a compressed representation of the information. However, in the realm of multimodal AI, we face a new problem. We need to represent all these modalities such as images, text, and video with one common embedding rather than having a different embeddings for each and every word. That's where we need data fusion. Data fusion is all about how we join the embeddings from multiple modalities to create one joint representation that represents all the input modalities. This simply means combining information from multiple sources or modalities such as text, images, and audio to represent them as one single embedding. Unlike the text input, text output LLMs, here the joint embeddings not just have the information about text, they have the information about audio, image, and video also. This joint embedding can be achieved through various fusion techniques. There are primarily two types of techniques we are going to discuss here. One is early fusion, other one is the late fusion. The early fusion is a technique used to combine data from different modalities such as text, image, text, images, and video at a very early stage of the data preprocessing pipeline. In early fusion, what happens is we'll have a separate preprocessing step for images and text. If you have a multimodal that understand text and images, we'll have a separate preprocessing component for images and text. And in the fusion stage, we'll fuse the embeddings of the preprocessed data. And the fused embedding will be fed to an output model, which will be further processed to do a task, something like a question answering or description generation, or we can fine tune to something like classification tasks. So one of the advantages of the early fusion in multimodal AI is it can understand intermodal connection. By combining different types of data like images, text, at a very early stage, AI can understand and capture complex relations between these modalities. This approach allows the AI to form a complete and detailed understanding. This comprehensive understanding helps the AI to answer questions more accurately and generate better description and make more informed decisions. One of the disadvantages of early fusion is the loss of modality-specific information. Even the combining data, different types of data at a very early stage seems like an efficient way, it leads to a problem. Each type of data has its unique features and nuances. When we merge them too early, we risk losing the special characteristics since we do the feature extraction technique after the fusion. This loss means AI might miss out on the important context and might lead to less accurate decisions. Another disadvantage of multimodal AI is the computational complexity. When we combine different types of data like images, text at a very early stage, it requires a lot of computational power. Processing and merging higher dimensional features at each type of data at an early stage can be really intensive and demanding. This increased complexity means the AI system might need more resources, such as powerful hardwares and a lot of time to process these informations. This makes it more challenging to implement and scale, especially for larger data sets. Next technique we are going to discuss in the fusion is the late fusion. In late fusion, each type of data is processed independently and produces its own output. These individual outputs, they are then aggregated, typically using methods such as averaging, voting, or weighted summing, or something like fancy techniques like ensemble, like stacking we can use to aggregate these outputs. The final decision or the output is derived from these aggregated results of the fusion, the output module. One of the advantage of this late fusion approach is it preserves the modality-specific information of each type of data. By combining information at the end, AI can understand and use rich details from each type of data, making smarter and more accurate decisions. Another advantages of late fusion is the less complex training. Late fusion simplifies the training process by allowing each type of data to be processed independently with its own specialized models, rather than requiring a single complex model to handle all types of data. This modular approach means that each modality can be trained and improved separately, which reduces the complexity and computational load in the training process by a lot. One of the disadvantages of late fusion is it does not use the intermodal connections at all. This means that it fails to combine and leverage the strength of different types of data through the processing stages. By the time the data is merged, the valuable interaction between these modalities will be missed. This leads to a less accurate and less robust outcomes. And finally, we have the most important and the output module of the multimodal AI. The output module is the decoder part of the multimodal AI architecture. In output module, what happens is the fused embeddings from the fusion model will be fed to a transformer decoder, and the output of the transformer decoder outputs tokens in an autoregressive way, and this token will be either fed to image decoder or text decoder based on the type of the token. Now you might have two questions. What is this autoregressive way, and how the model know which type of token to be fed to a text decoder or which type of token to send to an image decoder? Let me explain that. Autoregressive way is basically predicting one token at a time based on the user input and already generated outputs. For the example, you can see how it's generating an answer for the user input, "Hi, how are you?" It's predicting one token at a time and use the user input and already generated output tokens to predict the next token. For example, to predict the word "fine," the model uses the user input, "Hi, how are you?" and the generated tokens like I and am to predict the word token "fine." But you can see there are some other tokens too here, like start and end. What are these? This is what we call the special tokens. It's usually ChatGPT, if we have a conversation with ChatGPT, they usually release these kind of tokens, but you won't see in the answer because they mask these tokens. So basically what LLM does is they are just good at predicting next token. So it will iteratively keep on predicting token, but how they know when to stop predicting tokens? So LLM actually use this special token like start and end to stop the prediction part. So as soon as LLMs predicts that end token, it will stop predicting. This is the process they use to stop generating an answer, or when to stop generating an answer. Actually, multimodal AI actually uses a similar kind of approach to categorize text tokens and image tokens. The transformer decoder in the multimodal AI continuously predict tokens one by one in autoregressive way. And by default, all the tokens will be sent to a text decoder. But when the model predicts a special token called SOI, or start of image token, it starts sending the following tokens to the image decoder. It continues sending tokens to image decoder until it predicts another special token called EOI, or end of image token. And then the remaining tokens will be again sent to text decoder and text decoder until it predicts another start of image token. This way, the model can generate both text and images as an output. This is just one way of structuring the output model. There are possibly other ways that GPT-4 possibly using some other ways to have multiple modalities. To summarize the training architecture, let me go through it again. The first, we separately encode each modality and create embeddings for each and every data input. Then in the fusion model, we'll combine all this embedding and create one fused embedding representing all the input modalities such as text, image, and audio. And then the fused embedding will be fed to a transformer decoder, and the transformer decoder will output a token in an auto-regressive way. And based on the token type, it will be either fed to an image decoder to create images or text decoder to create text. By this approach, we'll get an output in multiple modalities. So hope you all understand this training architecture. So far, we have talked about how we train multimodal AI by using different types of data like text, images, and audio. But training multimodal AI isn't easy. There are many challenges and problems that come up during the process. Let's look at some of these challenges and understand why these tasks can be so difficult. One of the main challenges in training multimodal AI system is the data availability. The challenge of data availability in training multimodal AI is really complex. We need vast and accurately labeled data set, and also we need diverse data set, diverse data set to develop effective AI system. The high quality and annotated multimodal data sets are often rare, and collecting and annotating such a data set can be resource intensive and can be really costly. And second, there's the issue of data diversity too. To train a multimodal AI system to perform well in the real world, our data must reflect the vast diversity and the diversity of real world scenarios. This means including data from different cultures, environment. So unfortunately, most of the available data set lack this diversity, leading to AI systems that may perform well in the control settings but falter in the varied real-life situations. Another challenge we have in multimodal AI system is the privacy. Unlike unimodal, which only use text, the multimodal system not just use text, it uses text, images, audio, video, gathering a lot of personal information. While this technology can be powerful, it raises big privacy concerns. For example, if an AI system uses social media posts and voice recording and surveillance footages, it can reveal sensitive details about our lives. This can lead to a misuse of our information. The privacy is especially important in areas like healthcare, where the patient's record and conversation with doctor must kept confidential. The researchers are working on ways to protect our data using methods like encryption and anonymization. And laws and policies are also keeping up to ensure our privacy. So training this multimodal AI system presents several challenges as we discussed. However, despite these challenges, the benefits of multimodal AI systems are significant and really impactful. When we successfully overcome these challenges, obstacles, multimodal AI can offer remarkably a lot of advantages. One of the advantages of multimodal AI system is the improved accuracy. Even though unimodal AI can be quite powerful, they often miss out on the bigger picture. Even the multimodal AI, on the other hand, combine different types of data all at once. The combination allows the AI to get a fuller and more complete understanding of the user input. So it also can handle like unexpected changes and noisy data better than unimodals. If one source of information is unclear, the AI can always rely on other information to fill the gaps in the user input. As we can see in the charts and table, the multimodal AI like GPT-4 and Gemini models beating all the unimodals by significant margin across a wide range of benchmarks, showing that the integration of multimodalities in AI make AI models understand world and context way better, that leads to more accurate answers. So another advantage of multimodal AI is provide better user interaction and experience. Unimodal AI relies on single type of data, just like text or just voice commands. While useful, these systems often fall short to provide seamless and natural user experience. The multimodal AI, however, combines different types of data such as text, images, voice, and even the gestures. This allows for more natural and intuitive interaction. This combination makes using technology more easier and more enjoyable. Now that we have understood the significant advantages of multimodal AI, let's look at how these benefits are used, benefits are applied in the real world. The multimodal AI is already making difference across various industries. Let's explore some of the exciting and impactful applications of multimodal AI. One of the applications of multimodal AI is the autonomous car. Autonomous cars rely on advanced systems to understand the world around them. Multimodal AI system can combine information from different sources like cameras, radars, and sensors to create a complete and accurate picture of the road and the surroundings. By combining all this input, the car can make better decisions and avoid accident and keep the passengers safe. Another application of multimodal AI is it helps health experts in the healthcare diagnostics. By combining data from medical images like X-rays and MRIs and using with written reports of patient history, AI system can provide a clearer and more complete picture of the patient's health. These AI systems help doctors identify issues that might be missed just by looking at the image or the patient's history. They analyze vast amount of data in seconds, this supporting doctors to make better decisions in a very less time. So multimodal AI is transforming the healthcare, making diagnostic faster, more accurate, and accessible to everyone. So another application of multimodal AI is it helps business in customer service and support. By combining text, voice, and images, AI-powered virtual assistants can understand and respond to customer inquiries more effectively than ever before. It can also provide like 24/7 support, reducing wait times and offering help at any time of the day. And this pic in the slide is from the OpenAI GPT-4 demo, where a guy shares his screen and asks ChatGPT to help to understand the code. This kind of functionality can be applied to other domains as well. For instance, like a customer service setting, a representative could share the screen to something like a ChatGPT to get a real-time assistance in something like a complex CRM software. So it can provide more faster and more accurate response to customer inquiries. This means they can provide quicker and accurate solutions, making customer experience smoother and more satisfying. These practical uses highlight how combining multiple types of data can lead to smarter and more effective solutions. Now let's take a step further and dive deeper into even more ambitious vision. Multimodal AI and its potential to contribute to artificial general intelligence, or AGI. While today's AI systems excel in specific tasks, AGI aims to create machines that possess ability to understand and learn and apply knowledge across a wide range of tasks, much like how we humans do. This simply means artificial general intelligence is a type of AI system that is capable of performing any intellectual or cognitive task that a human can do. Multimodal AI, with its capabilities to integrate and process various information, is a critical step towards the AGI. Let's look at some of the features of multimodal AI that helping us towards the envisioned AGI. One of the features of multimodal AI that taking us in the path of AGI is its robustness and the flexibility. Combining multiple modalities makes AI system more robust and more flexible. If one modality fails to provide a complete information, the system can rely on other modalities to maintain the functionality go on. This adaptability and the redundancy and the adaptability in the machines are the characteristics of intelligent system behavior are vital for something like an AGI, which must operate reliably across various situations and conditions. Another features of multimodal AI that helping us towards the AGI is its enhanced world interactions. The multimodal AI enables more natural and effective interactions between humans and machines. By understanding and generating multiple forms of communication such as speech, text, and visual cues, the system can engage in more human-like conversations. This capability is essential for AGI, which aims to interact seamlessly with humans. And this is a very important feature. That these are features that help us to in the vision of envisioned AGI. And that brings us to the end of our presentation today. And so we have journeyed through the exciting world of multimodal AI, exploring its capabilities, challenges, and applications. And we have seen how it's revolutionizing various industries such as healthcare and customer service. While we are still far from achieving AGI, multimodal AI is still a critical stepping stone towards AGI. As we push the boundaries in the AI research and development, we'll continue to see advancement in the multimodal AI. This will lead to even more powerful tools and applications that can help us solve some of the world's most pressing problems. And yeah, that's for the day, and hope you all found the discussion informative. And thank you for joining me in this discussion today on the multimodal AI. Thank you all.
That's it.